you can run BC3 would force.
Let me move on here.
Okay.
Again, the labs are really just monkey business to get you to run the tools, but I'm trying to add in some interesting things to look at, which is why I was doing the MD5 sum to create raw I/O and cached read I/O without any writes going on yet.
Right.
So let me go off here. I'm going to go to my VNC viewer. So let's see where we are with the system. I'm going to just do a SAR 1-5. 4 is good enough. And basically a little bit of user time, a little bit of I/O wait time, but not much else. I'm going to bring up a top. Oops. And that MD5 sum is still running, and I'm just looking at the cache field getting a little bit bigger there. Notice there was a trim along the way. The buffers. The buffers are back down now. We had a trim happen. Let me do something here. I'm going to break out a top. I'm going to do a StarDash capital R. No, little r, sorry. So even in the last 10 minutes, 1140 was the last sample. In the last 8 minutes, we had a trim. So 8 minutes ago, we were at that full size, and then it got trimmed. And notice it's my cache that's growing now from the read. And right now I've got 83% of my memory busy. The trim probably happened when I started filling up nodes. K-swap D will pop in on a per node basis. Let's just take a look here. I'm going to do an I. I don't see any K-swap Ds. I'm going to do a PS-E and grep for K-swap. No real CPU time to them either. They've not been in any pressure situation. A StarDash, Big B, and I'm not seeing any page scans or anything. So there was some sort of clean or trim that wasn't even part of K-swap D that threw away what was in that buffs field. By the way, in StarDash Big B, these are pages paged in, pages paged out. So that's my I/O, including swapping. Faults per second are my TLB misses, a minor page fault, meaning that I had to go to the kernel page table to get the physical address for a logical address the program has. And then major page fault says I had to go to disk. Major page faults may include not going to swap, but going to the file system to get executables. So when we run out of memory, we will throw away the executables and not swap them, and then we have to go back to the file system to get them again. And then we got pages being allocated, and then here are the pages being freed. Now this data is actually coming out of that command, or coming out of /proc/VMstat, or VMstat. Let me try it. And in there, here are the pages paged in, pages paged out. Since boot, these numbers are since boot, where SAR was actually putting them in an interval based during that 2-second, or in last case was 10-minute interval. Let's see. And then those steals and page scans, these are what we were seeing as well. StarDash B. And look at, we now do see some page steals that happened. So now we can, looks like to me, we can see that trim. So here's where we see it dropping down, and now we see the trim from K-swap D, even though I didn't see any CPU time associated with it. We okay with that? And by the way, there's one thing here that says, of the pages we scanned, how many did we throw away? 99% of the pages that were looked at were dealt with. So that was a good efficiency on it. Any questions there right now? I'm going to try in a free command. There we can see the cache growing. Okay. So I'm going to leave that going right now. the next thing I wanted to do now was I was going to go through the lab, and I'm going to use the workbook has you SSHing to it if you're on a Linux system or X11 system, but I'm just going to use the VNC viewer. It says or the VNC viewer. So I'm going to invoke a PM chart -H, and I should probably change this. I don't want Kramer anymore. We're going to use Floyd 3 in my example, .sgi.com. So before I was running on my netbook Windows environment, this is now running entirely on the UV. I would normally not do that. That is just for practice if you don't have, you know, an X11 in your environment. But normally I would want my GUI local and use a network socket connection to monitor things. Do I still have PM chart there? And I do still see PM chart here. Okay?
Right.
Let me get rid of this. So that was step one. I'm then going to open the other thing I can do here. It kind of shows here I'm going to do an open view. And in here then is my host name, so I could actually click in here and pick a different host. Let me try localhost just to see what that does. And then I can pick a view. So move the cursor into the PCP Charts window, left click down on the File button, and select the Open View. I'm at the top of page 5.5. So I've got an Open View situation here. Step 3, move the Open View to the right so you can see PM Chart underneath it and open, and the Open View box, dialog box at the same time. Make sure you're connected to the right system. So I've had students connect to the Floyd 3 when they were running their labs on Floyd 1, for example. If not the right host, then select the monitor icon on the right side of the Open View and enter the host name. So that's what we were just doing. So I'm going to select the CPU utilization button again and click Open. And over on the left now, step 4, the PM chart should now get a chart of the CPU utilization, which is what we had before. Now I'm going to build a chart that I personally like to have open, and I'm going to do an open view and get swap next. So I can see if swap has swap allocations going on. So this is swap used. And I have 2 charts in here now. Now I'm going to open for step 6 my own view. I'm going to create a new chart. So this is what I was demonstrating earlier. And what I want to do is create a memory chart. Now, having had some background from IRIX and GrossView, I basically am trying to build a memory utilization stack chart similar to that, to show my kernel, my caches, my apps, and everything in one memory utilization chart. So I'm going to go into step 7, click on the mem. There it is. Actually, let me move this to the right so I can see my other chart. And then util, and again, a PM info-t would tell me where to find these things. And the workbook's a little old. Or no, wait a second, sorry. Step 8, I'm going to add slab first. I need to warn you that there is no 0 point to the stack bar. If the slab is big, it's going to start off bigger than 0. So I'm going to select slab there, hit the add to plot, and it's over here. Now this is all personal preference. The next one I'm going to add in is, so the slab was the kernel heap, and slab top would tell me what that is. Then I'm going to add buffmem. And buffmem is what we were just seeing with the raw I/O, anything that's in /dev. I should say any /dev block device We don't see character devices or tape in buffmem, just block devices. So we're going to add buffmem. That's my raw I/O, meaning there's no file system, there's no superblock, no directories, no inodes. Then we're going to add dirty. Now, dirty is data that my program has written. It has moved or copied from user stack or data space. Remember, automatic arrays might be on the stack, or if you've allocated on the heap, that's in the data segment. So if I write that stuff to disk, to a block device, it gets copied from my user space into a kernel page cache buffer, and that is marked as dirty. Dirty data is data that is incoherent, has not flushed to disk yet. A sync command would flush it to disk, and then it would be coherent. Also, the flush daemon may wake up and periodically flush it based upon how much memory is dirty or how long it's been dirty. Now, we're not covering the flush daemon settings this week. That's the advanced sysadmin class. So dirty is data that would get lost if I had a power interruption or a service interruption. And I kind of like dirty to be read. That's my dangerous stuff. And again, 40% of my memory by default can be dirty, and I cannot throw away, trim, or recover that dirty memory until it's flushed. Now, once the flush daemon marks it to flush, then we have what's called write back. So write back is data, let's see where it is right there, that has been flagged and marked to flush. So it's in the process of being moved off to the controllers and off to disk. You generally do not want to see write backs. Now, I had a problem at one site. They were running ×10, a memory resident database engine, and it was doing periodic checkpoints. And the checkpoints were checkpointing before the prior checkpoint was done. And there was a ton of write-back data on that system. I mean, we were talking 4 to 6 terabytes of write-back data on a 16-terabyte machine. If your file system can't keep up, you're going to see write-backs, but you should not see them by default. Solution at that site, other than redesigning file systems, was to throttle back on the checkpointing so it wasn't checkpointing every second, for example, if it took 30 seconds to flush that stuff to disk. This is what I call a flush choke. I don't want to start writing data if the prior flush is not finished yet. So if you see write-backs, your flushes are probably choking. Your file system can't keep up. Either back off on the dirty data writes, and in this site we actually did drop down dirty ratio and dirty background ratio so we didn't get too much dirty, and also reduced the amount of checkpoints being done to reduce the writes to the dirty write-back counters. So you shouldn't see write-backs. If you do, there's something going on there. Your file system is not keeping up. You're choking your file system. Now, if I am going right back to an NFS file system server, then it goes from dirty to write back to NFS unstable. See, I do have NFS unstable right there. So this is still incoherent, corruptible data that still has to get flushed to the NFS server. Once it's flushed, then that unstable becomes clean. So dirty writeback, NFS unstable is data that's incoherent and does not exist on the platter yet. Now, after NFS unstable, I'm going to add in cache clean. Now, cache clean is a PCP-derived metric. It does not come out of Meminfo. Let me bring up a field here. Oops. So only PCP is deriving that thing. And basically, the cache clean is the used field minus the dirty plus the write back. Now, it bracket here should include NFS unstable and I have a PV on that. When we created the Cache Clean metric in PCP, NFS unstable is not available yet. So basically what we're trying to do here is say Cache Clean is data that is coherent, identical in memory as it is out on the disk. I do have to be careful because of RAID controller caches and spindle caches. So when I get the dirty write back to clean, the clean is off the central memory or the main memory of the server, but it could still be existing on caches on the RAID controller or caches on the spindle and not be to the actual platter yet. So some sites will actually try to turn off write cache so that they know that the data got to the platter before they get their I.O. done. Now, one of the problems here is otherwise I get the data moved off to the RAID controller cache, I get an I.O. done, then the RAID controller might move it to the spindle. There might be errors there, and now I don't know. I've already told the application the I.O. is done, but in fact we've got corrupt data. So Cache Clean should include the NFS unstable. And then Cache Clean does include, and I need to do this right now, cached in Meminfo includes the dirty, the write back, the NFS, the NFS unstable, the Cache Clean. It's also including shared text. Now, this is the thing. Some people think that when I run out of memory and I start swapping, that the swap I.O. is a performance problem. It's not so much the swap I.O., it's the fact that I've trimmed my cache to 0 and thrown away my shared text, and the bash shell, for example, is no longer in memory. So you can see times when the cache field actually gets to 0. Now you got to go back to disk and actually get the bash shell or the library that's missing. And if swap is on that disk, now you're contending for the swap I.O. to be able to get your executable. So shared text is in the cached portion. When you do a BC free that we mentioned, or drop caches that we'll talk about, that throws away shared text. And you usually see some disk reads immediately after it bringing back all the DSOs and shared text that are needed. One thing that Linux really needs is a floor to the cache, such that when I run out of memory and trim it down, I don't trim it to 0 and leave some room for the executables. Also in the cache field is tempfs, which is memory resident file systems. And that does include /dev/shmem, and it includes the IPCS-AM shared text. And both of those are in this cached field. Now, the only thing that BC3 can throw away here is the clean, and the shared text. It cannot throw away shared memory, shmem type of stuff. It can't do anything with tempfs, and it can't do anything with dirty write back or NFS unstable. Now, in Meminfo, there is a shmem field that describes both the IPCS and the, this one is the shemctl system calls. And then this one is, for example, if I were to do a, if I were to do a DD /dev/0 into /dev/shmem/big file. So BC free can only do those two. the other option is to do a VM.drop caches, which will trim this stuff as well. The only thing that will free up this stuff is a sync. The flush daemon, oops. Okay?
Okay.
So what I'm trying to do in my stack bar chart is pull apart that cached field. So I was trying to talk about cache clean. This is something that PCP is deriving. And if I go back to the free command, basically what I'm trying to do is get this one here, which is basically saying if we take used, I should back myself up. If we take used and subtract from it the buffers and the cached, this is everything else right here. And then plus, if we take free and add that stuff, this is the available. This is kind of cache clean here. And this is everything but cache clean. Let me go back to PM chart now. I'm going to make these numbers do something here. So after cache clean, then I'm going to Anon Pages. This is my application space. This does not include shared text. It does not include Shemem, but it is the data segment and the stack segment. Also, I'm going to add in mapped. And mapped is my Shemem stuff. Now, unfortunately, mapped is going to get multiple counted here. It will show up in both the cached field and in the mapped. So we're going to actually see that effect happen a little bit later. So mapped is my shared memory, my Shemem stuff, and then I'm going to do free. And apply. So now I've kind of built my stack chart. I'm going to do an apply. Let me just cancel. Now, I do have a bug visible here. Notice that all these things are blue. If I click on this chart here, notice that those went black. Let me try clicking again. Let me click here, click back here. Notice now that the chart that I click in will be the active chart. And that one should only have the blue. I've reported this bug, but nobody cares or is not seeing it. So now that I've got that chart selected, I'm going to edit that chart. Now I want to change it to a stack bar. I'm going to add a title. And also, let me apply that. And now I'm able to see my memory utilization in a stack bar chart. And I'm seeing it all brown.
Cache clean.
Yeah. And let me come back to that. One other thing I might do here, I might go into plots. And maybe I want free to be green. I'm going to select the green there and then apply it. And maybe I'll take Anon Pages and make that a blue. Let me brighten it a little bit. I want to get it even brighter, just personal preference. Apply that. And maybe I'm going to take mapped and make that one black. And I'm just kind of randomly picking. I like warning stuff to be red. I like free to be green. And I like process space to be blue. That's the basic idea here. So I'm going to apply that. Let's take a look at cache clean. Kind of a brownish. We're just wondering if I can get it a little bit lighter and still be brown. Try that one. And apply. I can also go to this and add metrics, take them out. So I could select a metric here, remove it from the chart, add it back in, that sort of thing. So moving on with the workbook. So I've got a top of page 5-6 showing me my memory stack that I had from the slab all the way up to mapped, and then free was being added there. So step 12, applied. I've already applied it. Now 13, I'm going to now just go in and add disk. So I've got CPU memory. Now I'm going to add disk, open view. I want to get the disk. Notice again where these files are coming from. So this is I/O operations, number of I/O operations or packets going. So at this point, you should have 4 charts in PM chart, CPU, swap, memory, and disk. Notice the memory chart had no title. So step 14 I've already done where I flipped it and watch this blue here. So if I click down here, I got my blue. That is the chart that I can actively edit and change things with. Okay. So 15 and 16 and 17 I've already done. So 18, put your cursor on the swap chart and click, and then notice the title change. So I'm going to go up here, and notice it went blue up here. Okay? So now I can do an edit chart on that one. Notice it's swap allocation. Left click on the metrics tab. Okay. And I'm just going to do something here. I'm going to take the, what did we want? Select free. I'm just kind of doing this for you. Get it. And then I want to add it back in. So I'm going to go to swap. Let me apply that. Now let me add it back in. Swap free. Add it to the left. And apply. Host name kind of changed, but I'm not going to worry about that right now. They're the same machine. I do want to change the color, though, and get that back to a green. Looks good. And apply. You do have the ability with PCP to put several systems together into a single chart, like load levels on a whole bunch of systems. So here now, used on the bottom, free on the top, and the intent being that when I run out of physical memory, I'm going to see things grow up onto the swap device and start filling up swap. Interesting, I do see some writes going on right now. One thing that's nice here, watch this. If I click on a particular legend color, it will take it out of the plot. And then I can see an individual color. Let me take a look at something here. That was step 20. And then step 21, I put it back in. And then 22, I changed the color. 23 is green, and the order was flipped. Okay, so now I'm going to save this view. And notice it's saving it in root.pcp PM chart. I'm going to just call this thing all. I do have the ability to save the host name in there, but I'm not going to do that. I want this to be generic. So now I've saved that thing. I'm just going to do a close chart, close chart, close chart, close chart. So now let's see, 25 showed where the path was in my home directory in .pcp PM chart. 26, I saved it as all, and then I quit PM chart in the workbook, but here I just deleted the charts. It wants me to look at that file now. So if I CD the .pcp, PM chart, there's my file, and if I do a VI on all, it's an ASCII file that I can make changes to. I can flip around, change metrics. So I've got the plot, the style, the name, the color, and then the actual metric. So maybe if I wanted to, I could have flipped free and used by editing it here rather than where I had it before. There's my slab buff dirty right back in non-free, my disks. So that's the raw file that could be sent to somebody and used by something. Step 29 was flipping the swap lines around. So 30, to invoke that chart again, I'm going to do a File, Open, View. I'm going to click on the people up here, and now I see that .pcp PM chart directory. I'm going to select that, make sure I'm on the right host, and click Open. So now I've got that same chart. Now the workbook lab exercise is not doing this, but I'm going to do something else now. I'm going to add a tab. I'm running out of space to do everything here. I can't see everything, particularly my memory chart. So I'm going to create a second tab here, go to Memory, and to save time, I'm just going to open View and bring in that view that I had, All. And now I'm just going to delete and close some of these charts. Close chart, logical swap. I'm going to close chart. I want memory. IOPS I'm going to close. I'm going to add in a new chart here. New chart, because I want to create my own. Mem, util, and I want Shemem this time on a separate chart. Shemem is going to get counted multiple times. Add that in. Apply. And now I can see I've got about 2 meg. By the way, again, I got that bug. They're all blue. I'm going to click in here, edit that chart, and add in a title. And I want to change it to a stack bar. So I got about 2 meg in shared text, or I mean in shared memory, Shemem. So now that I like that, I'm going to do a file, save, view, and this one I'll call memory, and do a save. And maybe I'm going to create a third tab now. I'm going to call this one VMstat. Click on that. File, new chart. I'm going to go into Mem, VMstat. And I might build several here, but I'm mostly interested in those trims. Case swap D steals. I want that. These are in number of pages rather than kbytes. I don't want activates and deactivates right now. I don't want allocates or freeze. Let me look at case swap D steals, inode steals. I'm looking for steals and trims. I want to see if case swap D comes in. So page, let's see, DMA. If you're on older i386s, you're going to have the DMA 32. The only one we see data in is the DMA. And case swap D, DMA. So I'm looking for memory trim, memory recoveries. You were asking about when that buff mem gets released. H steal DMAs. Some of these are new for me with this new kernel. I haven't really looked at them. And that's good enough for me. I think I'll do a zone reclaim failed too. Apply that. Now I'm going to, before I generate it, put this. I'm not sure I want this in a stack bar. This is /proc VMstat or StarDash-B type of data. And everything's at a 0 right now. So let me save that off as well. Now, one of the nice things here is that these are all going to be time aligned so that I can pop between tabs and pull things apart. Let me check on my samples. Make this super big. Okay, so now I'm ready. The view you just created should be there on 31. So we had what did we create? The all 31 is basically looking at the all. Now, what I'm going to do now is record this stuff. This should have been on, just checking, yeah. This is on the Floyd 3, not on my netbook. Let me hit record here, start. Notice where it's saving the data now, and I hit an OK. And it's kind of hard to see here right now. Let me scroll down a little bit. See, the red button indicates I'm now recording. Okay, that's step 32. Step 33 now, I want to get some memory activity going on. Oh, let's see what we got here. Now, standard Linux comes with something called Memhog. If I do an RPM-QF /user bin Memhog, it's in the NumaCTL package, but there's no man page for it. So it's an easy way of creating a memory pressure situation. In fact, SGI's BC Free will use Memhog to recover memory on a per node basis. Or if you're not root, you can't write to drop caches. And it will use Memhog to force the trim rather than telling the kernel to do a trim. So let me do a Memhog -R, oops, what we got here? -R 100, let me go 1,000, let me go 2 gigabytes, let me go 20 gig here. I'm on a bigger system here. I want to fire off a bunch of these things and watch what's happening. I'm going to go to memory here. Now notice again, I got this one chart here. I can click on something and it goes away. Let me get rid of that buff mem. Am I on the right system right now? Top. Those memhogs aren't running yet. Something went wrong there. Let me do it without the -R option. Okay. So I'm going to try this again. I want to redirect the standard out and standard error. And fire off a bunch of these things. So I'm trying to create a memory pressure situation now. And remember, all the stuff is being recorded. So there I can actually see now the blue. Again, it is confusing with the other blue, but if I click on this one, I can see that those are Anon Pages, which is my process space. Let me bring up a top. Let me go back into here. I'm going to add these back in. There's my cache clean, and we can now see at one point where I started trimming the cache. Again, the first thing you normally trim is the slab, then the cache, then you start swapping processes. Presently, I still have nothing on my swap device. There's all my Memhogs. They're going to go to 20 gig. They're slowly growing. I'm going to do an F here and get the Y, the Wcan in there. And I can see they're all in user, they're 100% CPU utilization. Look at, I have 59% system time right now. Let's see here. There we are. So a SAR one space far, for example, I'm sitting there at 60% system time right now. Now if I do a perf top, I want to see what that shows. And here I am seeing memory allocation. I'm seeing copy page, clear page, isolate free pages as it's trying to trim things, and then this raw spin lock IRQ. That's most of my system time. But I'm not able to actually see how I got there. This is showing me what CPU, what subroutines my CPUs are in, but not how I got there. Let me see if I can get a PS-E and grep for Memhog. And I'm going to go into a crash. No, let's do crash. And then I need /boot / I have to have debug info installed. 480554. I'm going to do a PS grep for Memhog tail. And how are we doing over here? So we continue. Let's go back to the live one here for a minute. We continue to see all that high system time as we're doing this trim, but we want to know what that system time is. This is taking too long. I'm trying to get a PID. Oops. Let me just pick one here. Okay, there we are with our PIDs. So I'm going to do a BT. I'm just going to pick the bottom there, 480554. And by the way, Gus, in a MPT situation, engineering has a script that will run a GDB backtrace on all the threads of a particular MPI application. So all I'm seeing here is CPU utilization. It's not sleeping on any Wcan, which we already know. So now let me try a GDB-P 480554. Let me do a backtrace. Oops. And we don't have enough symbol tables, but it looks like it's sitting there in a MEMstat SSE2 type of routine coming out of glibc. Memhog, it doesn't have enough symbol tables to tell me what the call stack looks like. We could take these addresses and try to map them into the program. Let me try that later with our own program when we've actually got symbol tables going. That system time still going? Yes. Notice now I'm going to go to Mem here. I'm going to get rid of Cache Clean. I'm going to get rid of Anon Pages. And my free, still down to about 12 gig. Trying to push it to swap. Trying to create a swap situation here. I'm just firing off some more of these things. There is a parameter, sysctl-a rep for, sysctl-a type rep min free k bytes, min underscore free. So I should get down to 225, actually about 500K. It's twice that setting. So I should be able to get it down to about 500K before we actually start swapping. But let's see what's going on here. I'm going to click here. I'm not seeing any swapping going on yet. Let me go back to here. I'm not seeing any memory trims on any of these statistics either. Let me just check something here, /proc/VMstat, and see where the statistics are showing. Oh, so they're not in DMA anymore. They're in normal. I need to look at the normal one now. I think that's fairly new. I am seeing some DMA 32s. So let me get out of here. So let's see, DMA. I'm going to switch that to normal. I'm getting a stall. There we are. Let me close this off. And then add a new tab. Calling it VMstat. Go to it. I'm still not getting it squeezed down very well. And file, open view. There's one that I just created. I just changed it. Now these numbers are since boot, but I'm not seeing anything there right now. So we'll see what happens with that. By the way, notice that I am seeing data dropping here. There's a lot of holes where I'm dropping data along the way. Let's go back here. So my system time is even higher now. Still not really going to swap. I got most of my memory allocated, but I'm still waiting for the swapping to start. Let me do something here. StarDash-R, 1-5. So I'm at 94% of my memory used. Let me do I still have a large cache at 2.6 gig. Let's see. StarDash big yes. And nothing is out on swap yet. So we're still not really swapping yet. Let me bring up top. There's all those Memhogs. I'm going to go to Wcan again. You can't really see any Wcans because they're all in system time. So step 33 on page 5-7, just trying to pick the right thing to actually get a swap allocation to occur. And I'm still at 9 gig free. What if I do a Memhog 100 gig? Let's see if that can push me. Oops, can't get that high. Can't even get that high. I'm out of memory to allocate. That one will work. So I do see my free memory still squeezing down, but it's still at 10 gig. This is a little bit easier on smaller systems. Now notice that Memhog normally would be printing out dots to say that it's growing, but it's just sitting there right now. Let me see what's in the workbook here. So 5.8, put your cursor on the mouse memory scroll bar, scroll down to see mem free, click on free, and it'll be taken off the chart. Add it back in. So I was just showing you how I manipulated that. I'm actually trying to look at just free. Try running MD5 sum. So this is where we left off, or started really. MD5 sum. Oops. Let me get Anon Pages back in there. Get Cache Clean back in there. It looks like all my memory right now is process space with the blue. If I click on Anon Pages, okay, I can see the free going on here. So there's another blue going on here. If you click on that, that is the MD5 sum reading in raw I/O. So 36, what metric is MD5 sum causing to grow? It's growing the buff mem because it's reading in through /dev SDB. There's no file system interface to it, and that is known as raw I/O. And watch top at the same time. So if I look at the Memhog and look at the virtual versus physical, now I'm going to do something here. I'm going to do a Shift capital O. And I'm going to sort by memory size instead of CPU hogs. So I want to sort by RES, which is Q. And I should see the Q change over here. There it is. It returned. And now I can see what's growing. These are all trying to get to 20 gig, but they're still sitting there at 9 gig. Again, they're spending all their time in the kernel and system time, and was all on that spin lock. Again, if I do a perf top, so a little bit is this isolate free pages, but quite a bit of it is this raw spin lock IRQ save. But again, we don't know how we got to that routine, what routine was causing this. Let me try something else here. If I look at an individual PID, so I'm going to do a perf top -P 480. I'm just picking the last one, 72. Oops. 480723. And there we can see that particular top, all of its system time is that raw spin lock IRQ, isolate free pages, and a couple other things in there. Zone watermark okay. Some flushes going on. But everything still is in the spin lock and isolate free pages. Now, what was that? Do it. Try this again. GDB on it. Are we starting to swap yet? Okay. So our free, I don't think we're swapping it. My free is still in the gigs. Still about 90% system time. I don't see any swap allocation going on yet. It's still 0. Let me do a backtrace on this thing. And again, I can't really see the routines in the program that got me to the Memhog. So this is the thing that's calling, doing the memory growth that's resulting in the trims that are going on right now. I'm going to also try a perf record. Now here I'm actually profiling it periodically and putting it into a file that I can then generate a report on. Now we're going to get into perf tomorrow. And I'm just going to decide that's been long enough for it. So I actually profiled that process and looked at its programmer 23,000 times and a perf report. By the way, it's got a scratch file here of perf.data. Not too bad. Perf report. I can use a different name, but this is just picking up the default. And here again we see the same thing, the raw spin lock IRQ, isolate free pages, raw spin lock, some other miscellaneous things. Here's part of my cache management, isolate the least recently used pages. Oh, here's a trim here too, shrink your page list. Drop buffers, that's for that buff mem, trying to trim the buffers. And here's perf itself actually going in and looking at hardware counters, the performance metric unit. Okay. So you can see it's kind of getting hard to actually force it to swap here. Going on with the workbook. I'm now going to go to edit and stop it. I'm sorry, record and stop it. I'm basically no longer recording. Tells me where the file was. I'm going to get rid of that. I'm going to go into .pcp, PM logger this time. And there's the recording that I just made. I got to get into the actual host name. And there's the raw archive files. Remember, I also have PM logger hopefully still running. And there's all the files since yesterday. Unfortunately, it looks like my cron event to clean them up was not working correctly. So I got the 9th and the 10th, but I've got 2 boots on the 10th. There was a cron event, PM logger daily, that should have cleaned them up and merged them into a single file per day. Okay. So those archive files, the one was from PM logger, the one was from the record button on PM chart. So now I can do a PM chart -A, and then you list the .o file that you want. Oops. Let me just use SPLAD 0. And notice it says archive here now, whereas before it was live and it also had a red record button when I was recording. So the first thing I got to do now is open up a view, and that view does have to be in the file. If a metric's not available there, it's not going to display properly. There was a file that I saw here that said what the view looked like. It looks like. So there's my recording. Now, if I click down here, I get a VCR type controller here. Oops. So now I can actually start playing the data. Hang on, I'm going to stop it here. I'm going to change my number of samples to get a larger interval. I can actually slide the slider around and take a look at things. So I can see right here where things started getting trimmed. There's where the workload actually started. So this sample is going from 12:23 to 12:43, about 20 minutes worth of data there. By the way, I can also control how quickly I go through the data. What I can't really do is see the whole thing all at once. If I speed it up, now you can see it going through the data much more quickly. So again, I didn't really see any swapping going on, but I went through the step 41 LS on the files, and then I did step 42 and looked at the files. Step 43, there is your own case study out there. I'm not going to do that right now, but I'm asking when does the workload start and end, at what time did the swap traffic start, when did high system time start and stop, how much memory ever got dirty, some questions out of that interval. Okay, any questions?
No.
At this point, I've kind of ended what the lab is doing. I suggest we take a break. I know I'm pushing it here, but let's come back in 15 minutes and move on to the performance evaluation module.
Okay.
I know it's pushing, getting into your lunchtime too, but let's see what we can do with the next section, and then we're just going to do one more piece, one more stretch.